Hello everyone, this is Unit 3, Lesson 9, and in this lesson we are going to identify and create arithmetic sequences by using the explicit and recursive formulas. Alright, so we're going to start right now just graphing the absolute value, an absolute value function. So we have f of x equals the absolute value of x minus 3 plus 2. Remember, use your calculator on this, and even if you know exactly what is happening with this right here and with this right here, if you memorized what the effect that the absolute value has on a function that's inside versus outside, even though you could just go ahead and put it into the calculator. So just talking about without the calculator, anytime it's inside the absolute value, remember at x minus 3, it actually moves opposite of what you feel like it should move. The negative 3, you'd think it would move to the left 3, but it doesn't. It moves to the right 3. So you could just put down on top this expected V shape moves to the right 3. And then the plus 2 on the outside is up 2. It's kind of like the y-intercept of it all. So in this picture, if you have your calculator right here, we're going to press y equals, and you could see that it's going to move to the right 3 and up 2. So the way we graph this is press y equals, you press math, you go over to the right, and you have absolute value already on for number 1. You press enter, and you're going to just put x minus 3 down, get out of the absolute value, and then put plus 2. If you press the graph, you could see it moves to the right 3 and up 2. That all being said, let's go ahead and graph this. I'm going to move this over here, and I'll make this a little bit bigger so you could possibly see a little bit of it. So I'm going to go to negative 5, 10. So negative 5 is 1, 2, 3, 4, 5, and 10 is up. There. Negative 4, 9 would be there. Negative 3, 8 would be there. You don't have to look at the calculator anymore. You just keep on going. Just check the y-intercept. 0, 5. 1, 4, 2, 3, 3, 2, right here, and then 4, 3. So that's where it really comes to a that point right there. This is the y-intercept, so like you can't really think of this plus 2 as being the y-intercept, but I kind of think of it in my head like, okay, it's going to go up 2. It's not going to actually cross at 2, but it's going to rise 2 from the parent as compared to the parent function. All right, so now we're going to just go up like this. And I'm not looking at my calculator now. I know that it goes up. I just want to check that 10, 9 is my last point that I could fit on the graph, and it is 10, 9. So I'm good. I get my ruler out, draw my straight line, and straight line. Go beyond that last point. Make sure to put arrows on it. And we can label it right up here, f of x equals absolute value of x plus 3 plus 2. And that's perfect. For these right here, you remember you could say evaluate. Evaluate, that means inside the parentheses. They're giving you the input inside the parentheses. They're giving you the x. So when x is 0, here it is on the graph. What's the y? It's 1, 2, 3, 4, 5. You can also do this on the calculator, but the graph is very easy for the first two. 1, 2, 3, 4. When x is -4, what's the y? It's 9. So I'm going over to the x of -4, then going up to see where the y is. This is -4, comma 9. And that's the reason why when you have an input of -4, you have an output of 9. Okay, one of the things that that they should or probably will do on any test is to give you an input that will be off the graph. So you can't use the graph to find out when the x is 40 what the y is. All right. So you can either substitute into here and figure it out into the function itself, where f of 40 you could actually go ahead and substitute in. So I could do this as 40 minus 3 plus 2. So the absolute value of 37 plus 2 is 37 plus 2, and that equals 39. And that's pretty easy to substitute in. If you don't want to substitute, you can actually take the calculator and go to when the x is 40. So now, like, you have the option of just go ahead and clicking this down, like actually like near 40 clicks. I'm going back up because I want to show you something. So instead of clicking down to 40, say if they had 100, you're going to click down to 100? No. So you're going to press second function window, right? You see this table start? It starts at 3. So realize that if I press second function graph, do you notice that I'm starting at 3? Yes. So we have second function table set, and I want to get to 40 right away, right? So then we press second function graph, and look, 40, 39. It jumps to it. If I wanted to start the table set at, let's say, 120, I could find out right away what the output is, 119. So that's basically what you do. I'm just going to set it back to the table start of 0. And that'll be back to 0. All right, and that's basically the ways that you could do it. All right, arithmetic sequence is a sequence created. It's a sequence of numbers created by adding or subtracting the same number repeatedly. So you're just going to find what like the pattern is here. All right, what the common difference is. And we call it a common difference because it's the difference between two numbers, yes, but it could be either subtraction or addition. So just remember that. You take a look at the first one. It's 5, 7, 9, 10. So how would you get to from 5 to 7, from 9 to 11, from 7 to 9, from 9 to 11? So what we say right here is that the common difference is 2. Because the 2, just go ahead and page with it. Because it's 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. So the common difference is 2. So take a look at this second one. 7 goes to 3. So obviously it's not adding, it's subtracting now. But the common difference could be a negative number. So what minus 7 equals 3? And if you can do that in your head, minus 4, right? And 3 minus 4 equals negative 1. The common difference has to be the same. So it is minus 4. It's negative 4. That's the common difference there. So we're going to try. So you make those loops and you see basically how we got from 3 to 2. Well, from 3 to 2, it looks like it's plus 5. And then plus 5 again. And then plus 5 again. So what's the common difference? It's 5. And you could put positive 5, but I mean, if you put 5, it's just kind of understood that it is positive 5. So in this part of the lesson, we're just going to drag the sequences to match the descriptions. So we have an arithmetic sequence with a common difference of 12. So which one has a common difference of 12? Just take a look. I'm going to start with the first one. 11 plus 12, yeah, that is 23. 23 plus 12 is 35. 35 plus 12 is 47. So I'm going to put that here. And that is a common difference of 12. All right, arithmetic sequence of -5. So let's just take a look at something that is -5 that we have. So we have 8 minus 5 equals -3, equals 3. 3 minus 5 equals -2. So that goes there. The arithmetic sequence with a common difference of +3. So we're just going to look over here. Let's see if this is something that we could use. 36 and 33, that's -3. So I have a common difference here of -3. I'm going to move it here. And then an arithmetic sequence with a common difference of +3. This looks like +3 to me, so I'm going to move it here. But this also looks like +3 to me. 16, 17, 18, 19, 21, 22, 23, 24. So this common difference is here as well. And then we're going to go 8 to 5, so that's a negative. 5, 6, 7, 8, good. That's 3, that's 3. So common difference of 3. So we used all of them and we had common differences. We just look at the pattern and we are able to identify that common difference that's happening from one number to the other. So let's look at the sequence of numbers. We have 3, 8, 13, 18, and 23. The ... at the end means what? You've seen the ... before, so what does it mean? And this means that this sequence goes on forever. And that's what it means. Just keeps on going. 3, 8, 13, 18, 23 are actual terms of this sequence. And now, just taking a look at this sequence, there are 5 terms in this sequence so far. 3 is identified as the first term. And you say that a sub 1 equals 3. A sub 1, the first term. A 8 is the second term of the sequence. So you say it a sub 2. A sub 2 is 8. 13 is the third term in the sequence. A sub 3 is 13. 18 is the fourth term, so a sub 4 is 18, and 23 is the fifth term, and a sub 5 is 23. A sub n, if you ever see that, is the nth term. And it's a term that we don't have yet, and we're just kind of looking for that term, a sub n. So consider this sequence 7, 11, 15, 19. Think of each term as an output of the function. So this is your input. Term number 1 is 7. That's the output, 7. Input is 2. Output is 11. Input is 3. Output is 15. 4 and 19. So you can think of this whole thing as a linear function. And since it's a linear function, you could use the common difference of the terms of an arithmetic sequence to write the function rule in y equals mx plus b for the sequence. Let n equal the number of terms in the sequence, the term number in the sequence, not the number of terms. Let n equal the term number in the sequence. So if we're talking about a sub n, we're talking about the nth term. We still didn't really don't know what we're talking about as far as the nth term. It could be any term. All right, could be a term that you're looking for. All right, so you have a sub 1 is 7. Then a sub 2. So just take a look at what we have here. This is the common difference. The common difference you could tell right now, and like the way this looks from 7 to 11. 7, 8, 9, 10, 11. That's plus 4. From 11 to 15, plus 4. And from 15 to 19, that is plus 4 as well. So the common difference when you are identifying an arithmetic sequence in an arithmetic sequence is very, very important. So the common difference in this one right here is 4. So we're going to put common difference down. Is 4. So this is called the arithmetic sequence. It's on the next page, but I just have it right here. Don't freak out about this formula. You do not have to memorize it. It is on the Algebra region reference sheet there. So reference guide sheet that they give you, all the formulas. So it's a sub n equals a sub 1. A sub 1 is the first term. So that in this term is 7. In this sequence is 7. Plus the n that you're looking for, the term that you're looking for, now it would be 2, term 2. Say if you don't have the term, and the term that you're looking for is 2, and you do 2 minus 1, and then times the d, which is the common difference. So let's just take a look at what these numbers mean, and then we'll just, focus in. A sub 2, right? If you didn't have it and they gave you the common difference, all you would do is add 7. So a sub 2, you would be looking for a sub 2 equals a sub 1. A sub 1 is 7 plus, and all you're doing is substitute it into the formula. You're looking for the second term, so it's 2 minus 1. I'm going by this. And the common difference is 4. So all of that would equal the second term is 11. So now you're looking for a sub 3 equals 7, which is the first term, plus 3 now, because you're looking for the third term, that's the n. 3 minus 1 times the common difference, which is 4, and the next one is 15. If you're looking for a sub 4, you would put the first term down plus a sub 4. You don't put a sub 4 down, but you put the fourth term down because you're looking for it, minus 1, and then times 4. That whole thing would be just 7 plus 4, which is 19. All right, a sub n, this is the first term here. This is your a sub n. This is the first term. So you're going to put this is a sub 1. This is the formula right here. Plus n minus 1 times the common difference. And that's the formula. That's the arithmetic sequence. All right. This comes in handy for when you need the 100th term. So you're not going to do this. You're not going to just keep on adding 4 down to the 100th term. So you just go ahead and use this formula, look it up on the reference sheet, and then use the formula to figure out the term. So here it is, the explicit formula, arithmetic sequence. For an arithmetic sequence, you could use the first term and the term number and the common difference to find the value of any given term. And this is the other form here. This is the arithmetic sequence that I gave you. This is the nth term. This is the first term, a sub 1. This is the term number that you're looking for, minus 1, and then times the common difference. Another way to write this is to write it a sub n equals a sub 1 plus d times n minus 1. The only difference is that the d is taken and put into the front of the parentheses in that n minus 1. The explicit formula is one where you do not need to know the value of the term before the term that you're looking for. All right, so you do not need to know that term. You don't need to know, like if you're looking for the 99th term, you don't need to know the value of the 98th term, right? But you do need to know the common difference and the term number that you're looking for, obviously, and the first term of the sequence, right? So you could use this formula to figure out what that 99th term is without knowing the 98th term. So you only need the first term, like I said, the common difference, and then the term that you are trying to find. So find the 10th term. This is an example. Summarize the process. Find the 10th term of this sequence. So you just look, okay. Determine the sequence if the sequence is arithmetic or not. We know it's arithmetic sequence because it's going down by 2. It's decreasing by 2 each time. Matter of fact, just by looking at it, you should probably know what the common difference is. And if you said the common difference is a -2, then you are correct. The common difference is -2. It is an arithmetic sequence. Because we subtracted to get from one term to the other. So common difference is -2 in this case. So let's go ahead and see exactly what a sub 1 is. A sub 1 is the first term. That is 32. We already said that the common difference is -2. So D is the common difference. The term that we're looking for in this question, they asked us to find the 10th term. So I'm going to go back down and put 10. And now that I have those three numbers, I can actually figure out what that 10th term is. So I'm going to go a sub 10 instead of a sub n equals a sub 1, which is 32, plus the common difference, which is -2. Notice that that is in the front of the parentheses now. I'm looking for the 10th term, so I'm putting n as 10. And then I'm just going to bring up my calculator and put this directly in. So I'm just going to press graph and clear this out and clear this out. So it's 32 plus a -2. I actually don't like it like that. I'm just going to go ahead and put that negative. I don't care. It doesn't matter. You could put it any way you want. Plus a -2. You could put -2. It really doesn't matter. So I'm going to put 32 minus, because it's plus minus, so it's just minus 2 I'm going to get that out of here. 32 minus 2 times 10 minus 1. And if you obviously know that's 9. And it is 14. So a sub 10 equals 14. And then once you substitute, you could simplify your explicit formula to make it easier to solve. Can you simplify this equation to create an equation equivalent to an explicit formula? Yes. And I actually, you would just distribute and stuff like that. So it's just easy to do in the calculator. I'm just going to go ahead and move this down for a second and just show you the step-by-step that I would do. And this is -20, obviously. -2 times -1 is +2. And then a sub 10, I would never do it this way, equals 32 minus 18. I put that directly into the calculator and roll with it. All right, and that's about it. And that's how you would use that explicit formula to identify what term they're looking for in an arithmetic sequence. So all of these are arithmetic sequences. So we're just going to practice. I'll do one with you right now, and then I'll just go ahead and put the answers down to the other. So we have to find the 3rd, the 10th, and the 13th term. So I'm just going to go ahead and just put a sub 1 on the top here, a sub 2, and then a sub 3, and then a sub 4. So that's the 4th term. This is the 3rd term. The 3rd term is given to you as 1. Then you have to figure out what the 10th term is. And you notice that I have the formula there because it's given. So I'm going to go a sub 10. Actually, I don't have to rewrite things. So a sub 10 is the first term, is the term that I'm looking for. The first term in this sequence is -5. And then plus the common difference. So I didn't figure out the common difference because the first one was given to me. So the common difference looks like it is a +3. So D equals 3. And that's very important. A sub 1 equals -5. So a sub 10 equals -5 plus the common difference of 3 times the term that you're looking for is 10 minus 1. So you could put that directly into your calculator, or you could just go ahead and do -5 plus 30 minus 3. I don't like doing it that way because I just don't like doing it that way. So this is 25 minus 3. That's 25 minus 3. And then just go ahead and put 22. So a sub 10 equals 22. Again, I'm not going to do it that way anymore because it really is annoying as far as the figuring it out goes. Just put it into the calculator and you're ready to go. So a sub 30. So a sub 1, I have to just go back up and say a sub 1 is -5. A sub 1 is -5. Plus a sub 30. So we are D. Remember, the D goes in first. So the common difference here is 3. We are looking for 30 minus 1. I'm going to grab my calculator, do negative plus 3 times 30 minus 1. Close in parentheses, and you get 82 for that one. A sub 30 equals 82. All right, and let me just highlight those answers. And that's it. So just remember, the most important thing when you're doing questions like this, identifying terms in an arithmetic sequence, is to identify right away what the common difference is. Obviously, you're going to identify what jump is being made to get from term to term. So if you, even if you can count on your fingers, 6.3, 7.3, 8, 9, 10, 11. So this looks like a +5. And the same thing goes, excuse me, for the other terms. So you're adding 5. So we could put right here that the common difference equals 5. And we could put a sub 1. We identify the first term as 6.3. So the a sub 3, so this is a sub 1, this is a sub 2, this is a sub 3, and this is a sub 4. A sub 3 is already known as 16.3. But a sub 10, you would have to use the formula, all right? Or you could jump to a sub 10, 5 by adding 5 to get to a sub 10. I don't want to do that. I just use the formula. So a sub 1 is 6.3. The common difference is 5 times the term that you're looking for, which is 10, minus 1. And that's the formula. You grab your calculator. I'm just going to move this over. And just put 6.3 plus 5 times 10 minus 1. And you press enter, you get 51.3. So a sub 10 equals 51.3. A sub 30, and I said that I would let you guys do this, but a sub 30, the first term is 6.3. The common difference is 5. The term that you're looking for is 30. You subtract it by 1. You grab your calculator. You do 6.3 plus 5 times 30 minus 1, and you close parenthesis, and you get 151.3. So a sub 30 equals 151.3. And let me highlight those. Those are your answers. Those are your terms. That's what they were looking for, and you have all three. All right, so there's simple right here. Determine whether or not each sequence is an arithmetic sequence. Explain why or why not. So obviously, you're looking to see if something is added or subtracted to get to the next term. If it's not, then it's not an arithmetic sequence. Go ahead, try those, press pause, and we'll come back. So take a look at your answers. The first one, the common difference is -2. The next term in the sequence is obtained by subtracting 2 to the prior term, so it is an arithmetic sequence. No, for the second one, you're not adding the same number. Should be a period there. The common difference is not the same, so it is not an arithmetic sequence. All right, so in online store number 3, let me just move this down. Online store charges $5 to ship 1 box. So I'm just going to make a sequence up here. Obviously, this is what they want me to do. $5 to ship 1 box. So I'm going to highlight. $10 to ship in 2 boxes. Write in an explicit formula to represent the amount of the online store pays to ship N boxes. Use the explicit formula to determine how much the online store charges when they would ship 11 items. And this is a real world explicit formula situation as far as the sequence goes. So I'm just going to write down the first number is 5. That is a sub 1. The second one, a sub 2, is 10, and then 15, and then 20, and then 25, and then I'm just going to put ... So a sub 1 is 5. The common difference is obviously 5. So it just says to write that explicit formula down. So we are going to write that explicit formula. Then we're going to use it to identify what that a sub 11 would be. So I'm just going to write a sub n. So I'm just going to substitute those numbers in. A sub 1, this is the formula, plus d times n minus 1. All right, you can look that formula up. So the explicit formula would be a sub n for any, right? They want you to write the formula down with the numbers in it. A sub 1 in this case is 5, plus the common difference, which is 5. And then n minus 1 stays the same because you're looking for, they just want the formula for n boxes. So we don't know what we're finding here. This is the one of the answers. This is the explicit formula for n boxes. But now it says use the explicit formula to determine how much the online store would charge when they we're shipping 11 boxes. So A sub 11 is what we're looking for. The first term is still 5, and the common difference is 5 still, but now the end turns is 11 because we are looking for the 11th term. So A sub 11 equals, and I can do it by hand here if because it's easy, 5 plus, and this is 11 minus 1 in the parentheses 10, so it's 5 plus 50. So A sub 11 is 55. So that is your, I'm just going to highlight that. That is your answer for the 11 boxes, the charges for 11 boxes. All right. Let me move this down. It's the same type of question. The cost to rent the bike is $28 for the first day, so I'm just going to put 28 down, and then it's $2 each day after that, so it's 30. I'm just going to put a couple down here, 32, 34, ... All right, so write an explicit formula for the nth day. So, and then use the formula to figure out the cost of renting the bike for 8 days. So pretty easy. The A sub 1, this is the formula, A sub 1 plus D, n minus 1, right? So the n term, which is going to stay n because they just want a random a formula to figure out any term. So the nth term stays A sub n. The A sub 1 is going to be replaced with 28. The common difference, they say, is 2, and obviously it's jumping by 2's, so we're going to put that 2 in, like that. And the term that we're looking for is n. We're going to leave that n, and that is the formula for any term that you could use that formula for. So now we are just going to put the 8th day in, A sub n, that's what we're looking for. The first term is 28. The common difference is 2, and the n gets replaced with 8 because we're looking for that. To do this by hand is easy enough. We have 28 plus 2 times 9. A sub 8 equals 28 plus 18. And that's 46, or it should be. 8 minus 1 is not 9. I made a mistake right there. So caught the mistake that is there, and that means this is 14. Be careful. That's why I use a calculator all the time, actually. And that's 14. And then this is 42. Nobody's going to look for all of that work. I mean, I would just put the formula down, though, and then put that directly into your calculator. The fast finisher, just take a look at it, see if you could answer it. How are the arithmetic sequences related to linear functions? And so the answer to the fast finisher, the terms are in a linear pattern. Arithmetic sequences are related to linear functions in that they have a constant rate of change. The one thing I did skip, let's just go back just 1 second to this right here. Once you substitute into this arithmetic sequence, remember for this one the common difference was -2 and the A sub 1 was the 32. So once you put it in for making A sub n, you could go ahead and actually solve this to create a linear equation, right? A y equals mx plus b. So I'm not going to put A sub n down, but I'll just put 32. And then -2 times n is -2n. and negative 2 times negative 1 is plus 2. So just think about the a sub n being a negative 2n plus 34. And that's y equals mx plus b. The slope is negative 2, the rate is negative 2, and the y-intercept is 34. And that's how they're, related there. So the terms are in a linear pattern. They have a constant rate of change. All right, here are some Regents questions. Just take a look at the patterns. Just remember also that you're counting if the pattern continues. So you're looking at the shaded boxes here. So what you do is count the shaded boxes. And if you're counting, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12. Then you have to just count these. And that's 16. And then count these. So this is this is representative of the first 3 terms. I'm putting dots all over the place. This is 20. So you could see that a sub 1 says, assuming the pattern continues, which formula determines a sub n, the number of shaded squares in the nth term. So you're just getting the formula for the nth term. That means any term. So a sub 1, though, you need to know that, and you need to know the common difference. So what's the common difference? The common difference is plus 4. So D equals 4. So if we're going to talk about a sub n equals a sub 1 plus d n minus 1. So let's go ahead and do some work over here. We have a sub n. That's what it's going to start with. A sub 1, it's definitely going to start with 12. The common difference is 4. And then we're going to leave this n because we're looking for the nth term minus 1. So just go ahead, just go a sub n and then do some distributive property there. 12 plus 4n minus 4. And then a sub n equals 4n minus 8, plus 8, sorry. And that's 2. So it's just like taking a sequence and creating a y equals mx plus b out of it. All right, a linear function. And that is it for that. This second question should be able to do. So they're telling you that the third term in an arithmetic sequence is 10, and the fifth term is 26. So I'm going to just go ahead and put down like lines. A sub 1, A sub 2, A sub 3. We know that A sub 3 is 10. A sub 4 and A sub 5. And we know that A sub 5 is 26. All right. If the first term is a sub 1, what's the equation for the nth term? So we don't have all the terms, so this is a little bit more difficult. But we can figure out the patterns, and if you're good with patterns, you'll be good with this. Just remember, from 10 to 26, this jump here is 16. So it might, like, if you understand patterns, this jump right here would be only half that 16, which is 8. So if this was 18, and then another 8 was added to it to get to 26, that would work. So if that's plus 8 each term, minus 8 back to this way, would be 2. And then minus 8 back to here would be negative 6. Now, just remember, going forward, this should be a common difference of 8. And then the a sub 1 is negative 6. So let me just check it out, though. Negative 6 plus 8 is 2. 2 plus 8 is 10. 10 plus 8, 18. 18 plus 8, 26. It works out. So now we could put together the a sub n, the arithmetic sequence. We could go a sub 1 is 6 plus the d, which is 8. And then we are looking for the n term, so we're leaving it that way, minus 1. That's the formula you could look up on the reference sheet. So a sub n equals negative 6. We're going to do distributive property plus 8n minus 8. So a sub n equals 8n minus 14. And 2 is your answer. All right, negative 6 minus 8, you combine like terms. Right, that is that. That's a tough Regents question, but just remember, you just use the patterns, use what they give you, write down just slowly a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. They give you the third and the fifth term. Figure out the pattern that's jumping from a sub 3 to a sub 5, and then you could figure out the pattern that jumps from a sub 3 to a sub 4, each term jump, and then work backwards. And that's that. All right, so here's a fact sheet. Recursive formula is the order of list of numbers defined by a starting value, starting number, and a rule to find that general term. Recursive formula requires you to know the value of another term, usually the preceding term, the term before. That's the recursive formula. To find the value of a specific term. So this is something different than what we've been actually covering here. We were covering explicit formulas. Now we're covering recursive formula. All right, recursive formula, again, is different than the explicit. Remember, explicit formula, and in an arithmetic sequence, you would have the first term. You would have figure out the common difference and stuff like that. So recursive formulas require you to know the value of another term. It doesn't have to be the first term. It just has to be the term that's before the term that you're looking for to find that value of a specific term. All right, so the two examples of a recursive formula are on the screen in front of you. A sub n equals a sub n minus 1. A sub n minus 1 is always the previous term. It's the term you're looking for minus 1. That's the previous term. So that's why it's important with a recursive formula to know the term that's before the term that you are looking for. All right, and we'll get into some questions. And then it's plus d, which is the common difference. And then this is a different formula, an example of that formula. We'll get to those, and then we'll go into what we're talking about here. All right, and it says directions. Write a recursive formula for each sequence. So what we're going to do is just write the recursive formula for the nth term. So this one right here in the example, you could see up here, you always have to go for that common difference. So that common difference right here is plus 2, plus 2, plus 2, and the plus 2. All right, so d equals 2. But unlike the other formula that we were using for the explicit, the recursive formula does not need to know what a sub 1 is. So what we do need to know, though, is the value of the prior term. So we're just putting this into a formula, not figuring anything out. You could see what this is right here. You're looking for a common difference first, so we're going to go ahead and just put those loops in. And it looks to me that it is plus 4, plus 4, plus 4, and plus 4. So the D right here, I'm just going to put plus 4. So this is a sub n. If I was writing a recursive formula for the nth term, I'm just going to leave n the way it is. Oh, sorry. N minus 1 plus the D, which is 4. So if you are looking for, like, say, the next term, which is 1, 2, 3, 4, 5, the sixth term, this would be 6, and then this would be 6. You would have to put this whole thing in as the prior term, and then you'd figure out the next term. We'll get into it, though. So now for this one, you're just going to figure out the common difference, and the common difference is negative 8. So I'm going to put D equals negative 8. So the recursive formula is A sub n equals A sub n minus 1 for the prior term plus, sorry, not plus this time, minus 8. Because that is the common difference. That's what you're doing. So when is a recursive formula more useful than an explicit formula for an arithmetic sequence? So it is more useful than an explicit formula when you have the previous term and not necessarily the first term, right? So if that first term is not there, it's not given, then it's not really, the recursive formula is more useful, right? To figure out what that next term is. All right, so it says explore. F of 1 equals 3. And f of n equals negative 2, f, and then n minus 1 plus 1, then f of 5, and they want the value of f of 5. All right? Okay, so here's our first question using the recursive formula that we have here. All right, so they give you f of 1, and then it's 3. So what we have to get f of 5. So the next thing that we have to do is to get f of 2, because we can't get f of 5 without getting the prior term, which is f of 4. So we have to work our way to f of 4. So we'll start with f of 2. So we're using this formula here that they give us. Then it's negative 2. And you see this f of n minus 1. This is the prior term. So I'm going to go and just put parentheses. And right before it, I put the f. And it's n minus 1. So I'm looking for the 2 minus 1. And then it's plus 1. So just take a look at what this is. It is f of 2 minus 1. F of 2 minus 1 is f of 1. So look, negative 2, f of 1 plus 1. 2 times f of 1. Negative 2 times f of 1. F of 1 is 3. So negative 2 times 3 plus 1. Negative 6 plus 1. F of 2 is negative 5. So now we have f of 2. Let's go to f of 3. Equals negative 2, same formula, then f n minus 1. We're looking for 3. So 3 minus 1 plus 1. So f of 3 equals negative 2 times f of 2. 3 minus 1 is 2. F of 2 is negative 5. plus 1. f of 3, negative 2 times negative 5 is 10. 10 plus 1 is 11. All right. And then continue. f of 4 equals negative 2 times f of n minus 1, which is 4 minus 1. That's the prior term, plus 1. So f of 4 equals negative 2 times f of 3. f of 3 is 11 plus 1. f of 4 equals negative 22 plus 1, negative 21. And then f of 5, I'm going to move this. I don't know why I put this here. f of 5 equals negative 2 f 5 minus 1 plus 1. f of 5 is negative 2 times f of 4. f of 4 is negative 21. That's the prior term. Plus 1. f of 5 equals negative 2 times negative 21. That is a positive 42. And plus 1 is 43. So that's the answer. And lots of that. All right. A sunflower is 3 inches tall at week 0 and grows 2 inches each week. Okay. Which function is shown below can be used to determine the height, f of n, of the sunflower in n weeks. Honestly, I would just try to break this down in an xy table. 0, 3 is 3 inches, and then first week 5, second week 7, third week grows 2 inches, 9, fourth week 11. I mean, this is y equals mx plus b here, so I mean you could easily get that the slope is the y-intercept is 3. So that's good. And the slope, you could do 5m equals 5 minus 3. And then 1 minus 0. You just break it down easy, like, so it's not very difficult. M is 2. So the y equals mx plus b equals 2x plus 3, and that's 2n plus 3, so this is good. So if it's that, then I'm just going to go and check to see if this equals 2n plus 3, 2x plus 3, or 2n plus 3. If you distribute it and simplify it, so this is 2n plus 3n plus 3, and that's 5n plus 3. That is not good. So right now we have 1, 3 only, no. 1 is an answer. 2 only, no. So 1 is definitely an answer. So it's 1 and 2, no, that's out. It has to be 3 as well. So I didn't even figure out what 3 was, but we'll just kind of go through it. The previous term plus 2, where f of 0 equals 3, that kind of works out. It works out because this, remember, is the previous term. Right? So if you have the previous, say it's 3 plus 2, and you're looking for the next term, that 3 plus 2 is 5. 5 plus 2 is 7. and that's it. Previous term plus 2. So that works out, and it just confirms that 3 is definitely part of that answer. Okay, so a father makes a deal with his son regarding his weekly allowance. The first year, I'm going to just highlight some, agrees to pay a weekly allowance of $10, and that's the first year. Every subsequent year, so I just set up a sub 1. It was 10 because that's the $10 that they gave as a weekly allowance. And then it says every subsequent year, which is the following year, the allowance is recalculated by doubling the previous year's weekly allowance. So that's 2 times whatever the weekly allowance was in the prior term. And then subtracting 8. So I just set this up here. It's 20 minus 8, which is a sub 2 would be 12. And then, so I'm just going to go to a sub 3 and then double, which is now you're going to start with doubling, and then the prior term is 12, and then minus 8. And let's just see, 24 minus 8, 24 minus 8 is 16. And then I'm just going to go one further and then just do a sub 4 equals 2 times the prior term, which is 16, minus 8, which is 32 minus 8, which is 24. And so the first two are out because these are linear equations. Like if this is not linear, all right? And so the increase gets, when you're doubling the prior term and then subtracting 8, that is not linear. So, so those don't work out. But if you look at number 3, 3 is your answer. A sub 1 equals 10. Right? And then if you put a sub 1 plus 1, that's a sub 2 equals 2 times a sub 1. 2 times a sub 1, this is a sub 1, with you're putting the 1 in here. This is 10 minus 8. That's exactly what I have. Then if you do a sub 3 equals 2 times the a sub 2, a sub 2 is 12. Times 12 minus 8. This is the same thing. So 3 is what the answer is. That works out. For number 4, Jan is using toothpicks to create patterns as shown below. So the first thing you do is count the toothpicks. There's 3 here. There's 1, 2, 3, 4, 5, 6, 7. 7 here. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 here. So based on the pattern, how many toothpicks will Jan use in figure 16? So if you're talking about let's focus on the common difference. That's plus 4, and this is plus 4. So difference is 4. The a sub 1 is 3. And here's the formula, right? So a sub n equals a sub 1 plus d times n minus 1. So we're looking for figure 16. So we're going to put a sub 16. The a sub 1 is still 3. The common difference is 4. And then 16 minus 1. So I'm going to grab my calculator instead of doing that by hand. And I'm going to clear this out and do 3 plus 4 times 16 minus 1, which is 15. And then we press enter and we get 63. a sub 16 is 63. And C is your answer. So it says which representation yields the same outcome as the sequence defined recursively below. A sub n, we're gonna a sub 1 is 3. A sub n is 2. We're gonna put that, replace it with 2 because we want to figure out that second term. See if 1 or 2 kind of works out, because a sub 1 is 3 for both of them. So it's either -1 as the a sub 2 or 7 as the a sub 2. So we're going to just go -4 plus, and this is right here what you're looking for. So this is a sub 2 minus 1. So that's the prior term. So a sub 2 is -4 plus a sub 1. A sub 1 is 3. So that's -1. So this one's out, and we know that -1 works out. So now I'm just going to go to a sub 3 and see if that's -5. I have -4 plus a sub 3 minus 1, which is a sub 2. So a sub 3 equals -4, and then a sub 2 is -1. So a sub 3 is -5. That works out as well. So let me try a sub 4. I'm just going to keep on going because I don't trust it. -4 plus, so this is 4 minus 1, which is a sub 3. -4 plus a sub 3, which is -5, that's -9. That works out. I'm just going to do one more. A sub 5 equals -4 plus 5 minus 1, which is a sub 4. A sub 4 is -9. And then a sub 5 equals -13. So this works out. 2 is your answer. I didn't even really check the rest of them. I don't have to. That sequence, which representation yields the same outcome as the sequence defined recursively below, is this number 2. All the numbers work out, and you're good to go. Okay, this is the challenge question. Just it's like f of 0 equals 2, f of n plus 1 equals -2 times f of n plus 3, right? That's the formula that you are going to use. And just remember, this is just the next, it's basically just the next term, and it's a way of them using the prior term to figure out the next term. All right, so if n is 0, we're going to have 0 here plus 1. So we're looking for f of 1. We have -2 times 2, because in here, this is what you're going to be putting in for the prior term. So f of 0 would be 2. So we're going to -2 times 2 plus 3. And -2 times 2 plus 3 is -1. So f of 1 is -1. Now we're looking for f of 2. So n now is 1. And we're -2 times -1 because f of 1 is -1. So that's why you're substituting it in here. And that's like kind of like that prior term thing that we were talking about. That means it's 2 plus 3, which is 5. F of 2 is equal to 5. And that one's a challenging question, but that's it. Just skipping to number 8 because we're running long with this video. It's very, very long. So the first term in the sequence, let's just say is a sub 1 is 4. A sub 2, we don't know what it is. A sub 3, we don't know what it is. A sub 4, we don't know what it is. A sub 5, which is the fifth term, is 16. So you just have to figure out the pattern. They're asking you what the common difference is. So I'm going to go with 3, let's say. I was thinking about 2, but I'm going to go with 3. So this, if this was plus 3, this would be 7. If this was plus 3, this would be 10, and then 13, and then it would continue plus 3, plus 3. So the common difference you could figure out by just use of 2 numbers and the pattern. The common difference is 3. All right, the sequence is defined recursively as a sub 1 is negative 3, and a sub n equals negative 2 times a n minus 1. So then a sub 4. So we're just basically going to put down a sub 1 equals negative 3. And we need that prior term to get to the other terms. So we're going to just start out with a sub 2 equals, and looking at the formula, it's negative 2. This is the prior term right here. All right, so n minus 1, which is 2 minus 1, is 1. So I'm just going to put negative 3 in for that, plus 2. So a sub 2 equals 6 plus 2, which is 8. Then we're going to go to a sub 3 equals negative 2 times the prior term, which is 8. 3 minus 1 is 2, and that's why I'm getting the prior term there, plus 2. So a sub 3 equals negative 16 plus 2. Negative 16 plus 2 is negative 14. And then a sub 4 finally is negative 2 times negative 14, prior term, plus 2. A sub 4 equals 28. 14 times 2, negative times negative is positive, 28, and this is 30. So a sub 4 is 30. And that's about it. Just again, another common difference one that we are just going to roll through. So a sub 1 is 2. A sub 2, we don't know. A sub 3, we don't know. A sub 4 is 26. I'm just going to go by 6. So this would be 6 would be 8, and then nope, it's not 6. So maybe 9. 9 would be 11. That's plus 9. And then plus 9 would be 20. Nope. So I'm going to go with 8. See, this is how you would have to do it if you don't know. So 8 is 10, then 18, 19, 20, 21, 22, 23, 24, 25, 26. So that means this would be 8. The common difference is 8 plus 8. Common difference is 8. Remember the explicit formula for the nth term. The formula is given. It's a sub n equals a sub 1 plus d times n minus 1. So a sub n, we're going to look for, we have a sub 1 is 4. So a sub 2, with the n term, you're just going to leave the n alone. A sub 1 is 4. We're going to put that in. And the common difference right now is a plus 1. So we're going to have 1 and then n minus 1. And that's all you do. All right. So the formula is a sub n equals a sub 1 plus d minus 1. A sub n, you're going to leave because they just want the nth term. A sub 1 is 8. The common difference is plus 8. And then n minus 1. Common difference, a sub n equals a sub 1 is negative 2. Plus the common difference, it's plus 1. And then n minus 1. It says find the common difference to write an arithmetic sequence to create the explicit form for each, then find the 5th, 10th, and 100th term of each sequence. So you would go ahead and you would find out the equation of the line by doing the a sub n. The common difference is 6 in this case. The a sub 1 is 10. You would substitute that in to the explicit formula of a sub n equals a sub 1, which is 10, plus the common difference of 6, and then n minus 1. You leave that n because you're just going to use distributive property, and then just figure out exactly what the y equals mx plus b is for this formula for this sequence. And I have down a sub n equals 6n plus 4. And now we could just go ahead and figure out the 5th, 10th, and 100th term of the sequence. You do a sub 5 equals 6 times 5 plus 4. So a sub 5 equals 34. And that's basically it. So a sub 10 equals 6 times 10 plus 4. A sub 10 equals 64. And a sub 100 equals 6 times 100 plus 4, 600, 604. All right, and that's about it. We're just going to skip to the exit slip here. And then just finish up with that. There's a pattern of blocks shown below. And go ahead, see if you could do this. Which pattern, if they're looking for, if a pattern of blocks continues, which formula could be used to determine the number of blocks in the nth term? That means any term. All right, so just go ahead and see if you can figure it out. Which formula, which one of these, or could be multiple, could determine the number of blocks in the nth term. So I just put down, I counted the blocks 1 and 2, like term 1, term 2, 3, and 4. What you see is what you get right there. A sub 1 is 2, and then D equals 4. That's the common difference. So I'm just going to go and figure out what the, if this formula works here. A sub 1 is 2. Sorry. A sub 1 has 1 block in it, so 1 plus 4 is 5. So that doesn't work. No good. So I'm going to go and cancel out those two. And then, so a sub 1 is 2. That's good right there. So if we're figuring out a sub 2 equals, and let's go ahead and figure this out, 2 minus 1 is 1. So that means a sub 1 is 2. 2 plus 4 is, a sub 2 would be 6. And that's what I get for the second one. So let me see, a sub 3 equals, if I'm going to do 3 minus 1, that's 2. 2 is 6, so 6 plus the 4, which is 10. That works. And then let me do it one more time. A sub 4 is 4 minus 1. A sub 4 minus 1, which is a sub 3. A sub 3 was 10. 10 plus 4 is 14. I get that. This is good. So a sub 1 equals 4 times 1 minus 2. That's 4 times 1 minus 2, which a sub 1 comes out to 2. That works so far. So this is 2. It's not 3 only, because 2 works. So C is your answer. But a sub 2 is 4 times 2, because n is 2, minus 2. 8 minus 2 is 6. And then a sub 3 equals 4 times 3, which is 12 minus 2. 12 minus 2 is 10. So this works. All right, C is your answer, and that's it. Hopefully this video helped. I know it's a tough lesson, but I just want to thank you for watching, and I'll see you next time.